Hey guys, welcome back to Scribblera. In today's lecture, we'll speak about alternating current circuits, which is the next module. So let's get started. So first is the circuit components. See, there are basically three circuit components. One is resistor, inductor, and capacitor. What does a resistor do? Resistor is generally opposes current flow. Okay, let's understand resistor use with an example, right? Okay, let's suppose you have a 1.2 volt LED and a 5 volt battery, right? If you connect the 5 volt directly to that 1.2 volt LED, this will lead the LED to burn, right? So to prevent this, to avoid this, we'll use resistor in between. The resistor, what it does means it limits the current from a 5 volt battery to 1.2 volt. So it reduces the 5 volt to 1.2 volt and it will give to the LED. So this is how the resistor works, and to measure the resistance value we'll use this Ohm's law thing, V is equal to IR, and this will dissipate energy in the form of heat. Right now, moving on to the next thing, which is inductor. Inductor and capacitor both functions the same, that it stores energy. Where inductor will store energy in the form of electromagnetic field and capacitor will store energy in the form of electrostatic field. This is the only difference between inductor and a capacitor. Inductor is denoted by the letter L and it's measured by Henry. And voltage across inductor is VL is equal to L into di by dt. It's nothing but I into L. Okay, just I, you have to just differentiate it. Alright, and current through inductor is 1 by L into integral V dt. If you study this inductor voltage and current formula, it's just capacitor voltage and current formula is just the opposite. It will be voltage of capacitor will be similar to the current of inductor. So I'll show you now. Right, what a capacitor does, it store energy in the form of electrostatic field, as I said, and it's denoted by C and it's measured in farad. Voltage across capacitor is 1 by C into integral I dt. It's similar to the current across inductor, right? And current through capacitor will be C into dV by dt. Alright, I hope this is clear. Now moving on to the very important concept, which is sinusoidal voltage. So what is this? If one complete wave is called as one cycle, meaning one crest and one trough. You guys know what is crest and trough, right? In a wave, if you have the upper part of the wave is called as a crest and the lower part of the wave is called as a trough. If you have one complete wave, then it is called as one cycle. All right, measure peak to peak value from the crest to trough, that is called as peak to peak value. In question they'll ask you to find peak to peak value by giving a wave, then you have to find like this. So we'll solve sums and all based on this. All right, so we all know that this is 0, this is 90, this is 180, this is 270 and this is 360, right? If both the waves start from 0 degree, then it is 0 degree phase shift. Alright, both the waves are in phase with each other, then it is 0 degree phase shift. Alright, if it starts from, so see, this wave 90 degree only, this wave starts. So if it starts like this is 90 degree phase shift. Alright. If it starts from this 180 degree, then it is 180 degree phase shift. If it starts from 360 degree, it's 360 degree phase shift. It's very simple as that. All right. Now moving on to resistor. Resistor, does it have any phasor properties? No. Resistor has no phase shift between voltage and current. So it has no phase shift, meaning it is 0 degree phase shift. All right. So yeah, this is 0 degree phase shift. All right. Now, inductor and capacitor both are 90 degree phase shift. But there is only one difference between inductor and capacitor is inductive current IL will lag behind voltage in inductor, whereas the current, if it leads the voltage, it is capacitance. Okay. If current lags voltage, it is inductor. If current leads voltage, it is capacitor. I hope I made this point clear. Alright, if current leads voltage, it is capacitor. If current lags voltage, it is inductor. Alright. Taka. Now coming on to the phasor. A phasor is a complex number that represents the amplitude and the phase of the signal. So what is that? See, you guys know, right? Z is equal to x plus iy. I, you will represent I as j here in BEEE generally. So yeah, I, j, anything. It's just a complex number. What is a complex number? Complex number is nothing but I is equal to root of -1. If it has a minus in a root, then that is called as a complex number. It's very basic. You guys know. I think you guys have studied from 12th standard. All right. Yeah. Where this x is a real part and this y is an imaginary part. If you have axis like this, x-axis and y-axis, x will be the real parts and y will be the imaginary part. All right. Now, polar form is r e power I theta. It's similar. So, instead of theta, I am representing it as phi, which is nothing but the phase of z. Alright. And r is a magnitude. And here you know, right? So, if you have an angle over x here, so what will be your x? It will be r cos theta. Alright. R cos theta and y will be r sin theta. So, what will be z? It's root of x square plus y square, right? Yeah, and theta is tan inverse of y by x. This also is very important. All right, so I hope it is clear. And I guess you guys know how to convert a complex number into angle. You can do it directly using calculator. If you don't know how to convert a complex number into a polar form in calculator, you just comment below. I'll make a separate video of how to make it. All right, so yeah. Now moving on to the next very important concept, that is impedance. Impedance is nothing but it's a vector sum of resistance, inductive reactance and capacitive reactance. What is this inductive? I know what is inductor, what is capacitance. What is an inductive reactance? Inductive reactance is generally represented by the letter XL. It's nothing but it's 2 pi f into, XL will be equal to 2 pi f into L. So if you know inductor, you can easily find inductive reactance by multiplying inductor into 2 pi into f frequency. Frequency also will be given in the question if they're asking you to find inductive reactance. Similar way, capacitive reactance means Xc will be 1 by 2 pi f into C. Alright, so this is what you guys have to remember. Alright, so we know that Z is equal to x plus jy, right? So here the real part will be the resistor because resistor have no phase shift. That's why resistor is a real part. And here imaginary part will be here first if only XL is given. XL means what? Inductive reactance is given. Inductive reactance. Capacitive reactance is given. It's because it's 1 by, right? So it is minus. It will be minus here. If both are given, XL minus XC. Alright. I hope it is clear. And yeah. Z is equal to root of r square plus x square. Theta is equal to tan inverse of x by r. If both XL and XC are given, then it is Z is equal to root of r square plus XL minus XC the whole square. Similar way, here also XL minus XC will come. If you want, I'll write. Theta is equal to tan inverse of XL minus XC by r. Alright, so this is how it works. I hope these formulas are very important to solve sums. They'll ask sum based on these formulas only. So I want you guys to remember every formula clearly. Now, impedance and capacitance in series and parallel. Alright. So we know that if two resistors are in series, then the formula what happens? Okay. So okay, I'll draw it here. Okay, if two resistors are in series, then the formula will be R1 plus R2. If two resistors are in parallel, then the formula is R1 R2 by R1 plus R2. Alright. So this is what resistor in series and parallel means. Similarly, similar to resistor, inductor works. If two inductors are in series, then it is L1 plus L2. If two inductors are in parallel, it's L1 L2 by L1 plus L2. Right? Whereas the capacitance works exactly opposite. If capacitance are in series with each other, it's C1 plus C2 by C1 C2. It's not C1 C2 by C1 plus C2. It's not this. Right? It's not this. It's this. Okay? So C1 plus C2 by C1 C2, it's exactly opposite. And if two capacitances are in parallel to each other, it's C1 plus C2. All right. Now moving on to problem. Okay, what are they asking you? Find the impedance, current, angle, voltage drops, VR and VL. Okay, what are the formulas we know? So, okay, first we have to find impedance, right? So, impedance we know that it's root of R square plus X square plus XL square, right? So, I have to find XL right now. So, XL will be, it's 2 pi F into L. F, you know, it's 10 kilohertz. Frequency is denoted by hertz, right? So this is what frequency is. And you know, inductor 50 millihenry. If you solve, you will find this. If you substitute the XL and R here, you can find the complex number Z. Alright. Now they are asking you to find current. Current will be I is equal to V by Z. With this formula, you can find, you know, voltage 10 volt and whatever Z you are getting it, that thing you have to just substitute it, you'll get the current. Then they are asking you to find the angle theta. Theta formula also, you know, tan inverse of X by R. Right? So, same thing. So, wait, we'll see. So, XL will be 2 pi F into L. So, first, why we are finding XL? To find impedance. Okay? Yeah. And theta will be tan inverse of X by R. Now, voltage drops, right? Now, theta, Z, everything we found. Voltage drop VR and VL, right? So voltage drop VR will be I into R, right? For I, we know R here, we have to know I. We know Z. So I is equal to V by Z. So we know this. So now with this formula we can find I. So this I can just substitute it here and I can find R. And VL will be I into X. Right? I hope this is right. Well, just substitute all the values and you'll get the answer. I hope this sum is clear, right? Right, let's move on to the next sum. The similar way here, capacitance is given. So first we have to find what? Capacitive reactance to find impedance. Okay, so it's the same thing. Z is equal to root of R square plus X square. Substitute it here, you will find impedance. Now we have to find angle theta. Angle theta will be tan inverse of X by R. Right, so you'll find it. Now we have to find what next is. So impedance we have done, angle theta done. Now current will be what? V by Z, right? So V by Z. All right. Now V is equal to IR because they are asking you to find the voltage drop across capacitance and resistance. All right. I hope this sum is also clear. If both are given, then it's XL minus XC. It's inductor minus reactance. So first we have to find capacitive reactance and inductive reactance. All right, with this formula. Then Z is equal to root of R square. So this is an important formula. This is an important formula. All right. Then we have to find tan inverse of. So this is also an important formula. So this substituted. Next is what? Current they are asking. Then voltage drop across resistance, voltage drop across capacitance, voltage drop across inductance. I hope it is clear, right? All right. Now, if resistance and inductance are in series, then, and also you have to note here they have given you some complex number. Means, J means it's nothing but 90-degree phase shift. Okay? It's minus J means it's minus 90-degree phase shift. So, this thing you have to be very clear. So, if J is given, so first IR. See, you know that parallel current divides. So you have to find the current. Alright, so IR is 20 by, so V by R, so 20 by 50, you'll get this. IL is V by X, so 20 by 0.3 angle 90. How angle 90 came? Because J is there. Alright. So just do it in calculator. It's very simple. So now I have to find the total current. So IR plus IL. Alright. Why we are finding current? To find VR. And you know that V is equal to IZ. So I don't know why my pen is working like this. Okay. Then Z is equal to V by I. Alright. Then theta is equal to tan inverse of R by XL. So you'll get the value. VR is equal to IR. VL is equal to IXL. I hope it is clear. Alright guys, so that's all about AC circuits and all the phase difference, angle, everything. I hope everything is clear. If you guys have any doubt, just comment below in the comment section. I'll be there to help you guys out. And thank you all. Please do subscribe to my channel to